So now I would like uh, to highlight this interface, which is an ICAR interface. And if you see this interface, it looks different than the abstract class or the concrete class, which we've already highlighted in the previous parts of this video series. We can see the declaration of this property speed, and we can also see declarations of these two functions, but there's no definition whatsoever. The definitions are all provided in the class called GreenCar, which is implementing this interface. Implementing is an interface is just like signing a contract, and the contract, according to the contract, you have to define all the functions and properties within the interface. So in the interface we have one property speed and two functions apply, brake, and accelerate. And by implementing this interface, you have to define all of these three members of the interface. Here we are defining this speed property, and we are also providing full implementation of GreenCar function. So we have an apply brake function over here, and we have an accelerate function over here. So that's something which you have to do when you are implementing an interface. You have to provide full implementation of all the members within the interface. So now if I run this very quickly, we can see the red car details, we can see blue car, and we can see in a similar fashion the details of green car. So if you're calling this function of apply brake and accelerate, and we can see it's working perfectly fine. Now the test which we've carried out for red car and blue car, we are going to carry out the same test in the green car class. So we are going to comment out accelerate and see what happens. Now as soon as I try to run this program, I see that there are some errors. And why does it, sorry, let's try to, so I'll do a no, and I'll see the error over here, and the error suggests that we have not implemented the accelerate function within the green car function, which is the violation of the contract. According to the contract, you have to provide full implementation of all the members of the interface. So that's the violation of the contract, and this violation is highlighted at compile time stage, which is definitely better than what we've seen in the concrete car class function. So a natural question at this stage would be, why would you ever prefer an interface? Because in the case of interface, we have to provide full implementation details within the child class, and if we have an other child class which we decide to have to be linked to this interface, in that new child class we'll have to again provide the full implementation details, and in a number of scenarios we may end up having a situation where those implementation details won't be that much different. So for example, if we have another class with the name of, let's say, amber car class, we would still have probably a similar apply brake function. So that doesn't seem very natural, and in those kind of scenarios, if you think about those kind of scenarios, probably abstract class is better, because In the case of abstract class, you would have just one implementation of this apply break function, and all the child classes which will be derived from abstract class function will have this implementation as a default implementation, and they would only need to implement the accelerate function, which is abstract in the scenario of abstract car, whereas in the case of interface, you would always have to provide all the implementation details of all the functions. Now let's say we have three classes which are implementing this iCar class function. Those three classes will have to provide their own implementation of apply break function. No matter the apply break function looks absolutely the same in all those three classes, but those three classes would have to implement their own apply break function. So that's definitely a downside of using interface, and abstract class definitely wins in those kind of scenarios. But you need to understand that in C# we don't have a concept of multiple inheritance. So let's say we have got a blue car over here, and blue car is extending is basically derived from abstract car class, but this blue car now cannot be implemented, cannot be derived from another class. So we cannot have a situation like this where blue car is derived from two different classes. So in those kind of scenarios, interface is better than an abstract class, because you can have a class which is implementing an interface, but at the same time it can implement another interface. So you can definitely have something like this, and this would be fine because you can implement as many interfaces as possible. The condition will remain the same. If you want to implement another interface, you'll have to go down at the very bottom and implement all the functions of this I and other interface. But again, you can implement multiple interfaces, but you can't derive a class from multiple classes. So this is just a short video series in which I tried to explain abstract class, concrete class, and interfaces, and some of their trade-offs.